Today we are going to see AWS security checklist. This is very important in security aspect of cloud, how you are going to maintain your security. This is specific to AWS. AWS has 5 pillars in well-architected review called cost, performance, security, fault tolerance, and then reliability. So these are the 5 pillars in AWS well-architected framework. Now we are going to look at the security pillar. The first major uh, service in AWS is IAM, which is Identity and Access Management. So we're going to see one by one what are the security checklist we need to follow when you are having a new AWS account, or you are going to have a new services, or new you're going to launch an AWS instance basically. The first one is Identity and Access Management. We call this as IAM. Secure your AWS account. We should secure our AWS account. There you can create multiple accounts, multi-account, multi-AZ, multi-region. But how are you going to secure an account? So you should use a service called AWS Organization to manage your accounts. So the AWS organization is kind of OU, organization unit, where under the organization unit you can have a management organization, production organization, development organization. Under the production organization, you can have prod 1, prod 2, prod 3, dev 1, dev 2, dev 3. So you should group your accounts in AWS organization. Use the root user by exception with multi-factor authentication enabled and configure account contents. It's very important that you always avoid using the root user and use multi-factor authentication. You will have your password and you will get your OTP. Every user using the AWS account will receive the OTP in their mobile. So when they put the OTP, it logs in. So it makes your account secure. And you should configure account contact. This is very much important, because if I'm only one account user, I forgot the password, the admin password or something, all the details will be sent to the account contacts. So it is always important we configure one or two people in your company as an account contacts. So any vulnerability attacks or any issues or anything AWS monitors in the account, they will send the details to this account contacts. So the first checklist is we should secure our AWS account when we provision the new account. Then second thing is rely on centralized identity provider. So when lot of users are there, or developers who's using your AWS accounts, everyone is going to authenticate to each and every account. So we should have no centralized identity provider. So one person can log into the account A, another person can log into account B, another person can log into account C. Still, all this should be captured in one single identity authorization. For that, AWS provides AWS Single Sign-On. The Single Sign-On is kind of a portal where once the user logins to the portal, you will see all the accounts there. So from the Single Sign-On, you will go to the account, whichever account he wants to go. So single sign-on is a service which also helps for this publishing all the accounts and applications for the customers, or you can use any third-party provider as well. So that is one thing. To avoid routinely creating IAM users or long-term access keys, this approach makes it easier to manage multiple AWS accounts and federated applications. So instead of managing all the logging to the IAM, you can also manage using the AWS single sign-on. So rely on centralized identity provider. You can capture all the audit logs of all the users who has logged into which account and who has not logged into which account. Everything you get it in one place. So now we will move on to the third checklist. Use multiple accounts to separate the workloads and workload stages such as production and non-production. So most of there is a topic which is there in best practices of AWS, how you can segregate the accounts. You can segregate the account based on the project, finance, marketing, business, uh, different projects in your office, or you can also segregate your accounts based on production, non-production, development, environment, or you can segregate your accounts based on no, based on different other criteria as well. But it's basically you should not rely on one single account to run all your workloads. That is your production and non-production. So the security aspect, you cannot maintain the security aspect pretty well. So always have multiple accounts, and as you know, AWS having multiple accounts is not going to cost you. The service or the application which is run on the accounts is going to cost you. Even it is one account or multiple accounts, the cost is going to be same. And no, allow the separate data enable the use of service control policy to implement the guardrails. Guardrails is just to get the logs. AWS Control Tower can help you easily set up and govern multi-account AWS infrastructure. As I mentioned, organization have multiple account, and multiple organizations can be managed by AWS Control Tower. So first, AWS Control Tower will have multiple organization. Under the multiple organizations, there will be multiple accounts. So if you want to set any policy globally for your all the accounts, you can also publish that policy on Control Tower. So all your accounts will have that policy published. So you can that is the you should have multiple accounts. That is the third uh, security checklist here. The fourth checklist is store and use secret securely. Secrets is nothing but your passwords, your sensitive authentication informations, your applications, account number, or if you are working in banking, you use dummy account numbers of your customers to test your application. Most cases it would be tokens because AWS use this passwords and tokens. All this you should not keep somewhere, or you should see how you secure you can do it. Where AWS offers AWS security token service, where you cannot use temporary credentials, you can use the credentials from AWS token service, and you can store that in AWS secret managers. Secret managers will by default encrypt, make password rotation policy, like every 30 days you have to change your tokens, and access control. So AWS offers the service called AWS Secrets Manager to store your secrets in the encrypted format, right? So we will see the we have seen these 4 points, key points in IAM. How you going to do the identity and access management. Now we are moving on to the detection. How you going to detect if there was any security incident is happening? That is very important. What are the services going to detect that? They enable the foundation services like AWS Cloud Trial, AWS Guard Duty, and AWS Security Hub. So I'm not going to talk detail about these services because AWS Guard Duty will help you in DDoS attack, and that is by default is going to monitor your infrastructure for any kind of hackers or DDoS attack basically. And a cloud trial is audit logs for API activities. Anyone is using the APIs of your applications, all the API logs you will have it in a cloud trial. So any, for example, your application is in US, but you see someone is from Europe is accessing your application, for example, right? So that particular log says one request is coming from different region or something. So that monitoring is very important. Audit monitoring that cloud trial gives, and guard duty is going to continuously monitor your infrastructure for any kind of attacks. Security hub is have a lot of different security like inspector, or a lot of different security logs. You can keep it in the security hub. So that is that is going to give the comprehensive of all logs. So we can talk that in detail in later sessions, but first you need to have in the account level, each account should have the cloud trial, guard duty, and security hub enabled. The second checklist in detection is configure service and application level logging. So it's important you monitor your application logs. That is very key. Enable logging at service level as well, such as service level means like the network layer, VPC, flow logs, the S3, cloud trial, elastic load balancer. This will gain access in for your events. Anything goes wrong in your applications. All this can be stored in one central account. Even though you have multiple account, you can store all in one S3 bucket, and you can protect them from manipulation or deletion. Like you can use hashing mechanism SHA-256 to put all this into the bucket by using the checksum, so no one can manipulate your logs. But ideally you need to have your application log enabled for your applications. And third key point is configure monitoring and alert and investigate the events. This is very important. The monitoring is the key area in security. This monitoring is talking about in terms of security, not in terms of operation. So you need to enable AWS config to track the history of resources, and config manage rules to automatically alert and remediate the changes for all the sources of events from AWS Cloud Trial and Guard Duty, and all your application logs, configure alerts, high priority events, investigate. So basically, your monitoring is going to give you the alerts. The alert is nothing but something goes wrong, so you can investigate what has happened. So these are the services checklist which AWS suggests us for detection. Now we move on to infrastructure protection. This is very important. How we going to protect it from the security vulnerability? Because if our infrastructure is more vulnerable, the way we set it up, then more people try to hack it. We can no detecting the hack is, once it is hacked, you are going to detect it by your cloud trial or no guard duty. But how to prevent it? No, that is the infrastructure protection. Patch your operating systems application and code. Of course you should always patch the packages provided by Windows, for example. No What are the latest patch in the market? Like you update your Android iOS application, you should always upgrade or put patches to your database and all the things you are running. So AWS has this AWS system manager patch manager service, where you can put patches to different systems from one place. Okay, this will make sure that you have all the patches in one place. Then you can implement distributed denial service DDoS protection, and for that you need to use AWS WAF, which is firewall, application firewall, web application firewall, and AWS Shield. So Shield, if you have Shield, the Guard Duty Shield, those are kind of similar service. And we use the CloudFront. CloudFront is the distribution layer on top of your web layer. On top of your load balancer, you will have this CloudFront, so that the user cannot directly come to your load balancer and access your application. Rather, he come to your CloudFront, and CloudFronts will have some kind of health monitoring system to protect your application. No, and the AWS WAF has the rules, IP whitelisting. You can give the source IP. You can do some filtering of traffic with the IP address that WAF will do. Shield will monitor the DDoS attack or any kind of attack. So the name says Shield, so it is a shield for your account. The third point is control access using VPC security groups and subnet layers. It's very important. Like you allow the port switches for your inbound and outbound traffic. If it is 8080 or 443, you should allow only 443, and SSH 22. No, that is security group you should allow. And there is AWS firewall manager, which is again the WAF is there as a application firewall. So it's very important. You should have the security policies and subnet access control in right place. Okay. Then we have this data protection. Now we are moving on to infrastructure protection to database protection. The infrastructure protection, more about it, talks about the security groups, denial of attack, and control the access in VPC. Now we are moving on to the data protection part. It's very important because if someone hacks our system, what he is looking for is our data, our business data. So first point is protect data as at rest. So the data which is there in the rest, which is not being used, how are you going to protect? You're going to use KMS, key management service, to protect the data. So the applications don't use username and password, or the database and the application which you connect, it should not be the username and password of your MySQL or MS SQL. It would be rather than having the AWS created keys from the key management service, which key management service will make the rotation policy and manage the application and the database. And we need to enable the default encryption in EBS volumes and S3 buckets. So whenever it's possible, you just enable your encryption policy so that the data which is there in your EBS volume or S3 bucket is going to be encrypted. So whoever tries to take the data out of that EBS without your knowledge, it's going to be the encrypted data. So that is the protect data at rest. The encrypted data transit. This is very important when someone is accessing your application during this network layer. Some packets can be no taken. So we need to encrypt the flow of your database and the application or to your no different applications when you're talking. So you need to encrypt your network traffic. You should use transport layer security for web-based network infrastructure you are controlling. It is a key exchange. You will have your certificate, PEM key, and your PPK key, like public, private, and public key. The key exchange will happen. That is, certificate exchange will happen. Then the connectivity establishes between the two nodes. Then the traffic happens. That is nothing but the key part. The service which we need to use here is AWS Certificate Manager to establish the TLS connection. And then the third point in data protection is use the mechanisms to keep people away from data. This is very important. We need to keep people away from the data and not everyone to access your sensitive data directly from the system. So AWS QuickSight dashboard for business users to direct access to AWS to perform actions. The business users who's non-technical to database, they can query from the quick insights and get the details from the database. They want to see the name of the person, so they won't have actual access to database. They will have the access to QuickSight where they can query it from that place. And we can also use distance action using AWS System Manager, automation documents, and run command. The AWS System Manager is going to run the commands on the database, so you don't need to have directly running onto database. So this way we should keep the people away from the direct access to our database. So now we saw the infrastructure protection, we saw the how to detect, then data protection. The final part is okay, there was some security uh, issue happened, then that should be considered as an incident. Whoever is in operations, they know about what is incident change and problem management. So now it becomes an incident. How you going to respond to the incident, which is which how in AWS is very important. Now you have an incident, so ensure you have an incident response IR plan. Begin your IR plan by building the runbooks to respond to unexpected events of your workloads. For example, AWS provides a runbook called AWS Security Incident Response Guide. So you should refer to AWS Security Incident Management Response Guide, or you should build your own runbooks based on the experience you face. So when the incident happens, you have something to refer and solve it. Because a security incident, we cannot take more time to research and resolve it. Make sure that someone is notified to take action on critical findings. Begin with guard duty findings, turn on guard duty and ensure someone with the ability to take actions receives the notification. Automatically create trouble tickets, best way to ensure that guard duty find integrated with your. So guard duty, as we discussed before, it going to detect your findings and it should notify someone that you should have the automated process. Once the guard duty is found, it's going to call the on-call person or it's going to create a ticket and assign to the security team. So that should be in a place when the detection is happened. You need to have someone notified. It can be SCS, simple email service to notify, or your Slack notification, or Teams, or WhatsApp. So you should have a way to make the operational process in place. This is very basic thing. Most people might be knowing it, but this is specific to security again. The third thing is practice responding to events. So when the event is happening, simulate and practice the incident response by running the game days, incorporating the lessons learned into your incident management plans, and continuously improving them. So we need to continuously have simulation, like what happens. Like we used to do this disaster recovery testing twice a year, considering one data center is down and how the traffic is switching, like a mock practice. The same way they are suggesting to have the security event when considering there's a security event happening, how the things is going to work. So in AWS they used to say game day, like actually everyone will be available and they will work as if that event is happened. So make sure everything in the place when the real incident happened. It take like kind of a COVID vaccine. You have a COVID vaccine and your body gets the immunity. So when the real virus come into our body, then our immunity attacks. So same way when we have that simulation, we know what we have to do when the thing comes. So it pretty much covers everything. You should run the well-architected framework for your infrastructure to identify how, so what is your security will be more of question and answer in well-architected review. I think this would be useful for most of them who's looking for best practices in security in AWS. And thanks, guys. And I'm going to discuss more about the AWS and cloud best practices in coming sessions. Thanks for watching and all the best.